Hi, everybody. My name is Dominic Seyler. I'm from the University of Illinois at Urbana-Champaign. And today I'd like to talk about finding contextually consistent information units in legal text. This is joint work with my advisor, Cheng Jai, and Paul Bruin and Pavan Bayapu from Rigology. The motivation behind this work is as follows. Terms in the law of a legislature can be highly contextual. For example, 26 USC states that the term person shall be construed to mean and include an individual, a trust, or a corporation. However, 42 USC states that the term person includes only one or more individuals, governments, or receivers. Also note that the first definition is applicable to the entire title, whereas the second definition is only applicable to the subchapter. Therefore, the context is not identical across corpus. We try to assist professionals when reading legal text by finding contextually consistent information units. And what these units are, I will explain later on. Our method is modeled to emulate what we call the contextualization process, which is made up of 3 steps. In the first step, the reader notices that the definition of person is not in the current section. In the second step, the reader needs to find the definition of person, which is applicable to the current section. And since there are many definitions of the word person, the reader has to know which is the correct one, which applies to that specific section he or she is reading. In the third step, the reader needs to understand which other sections this definition applies to. As mentioned earlier, the goal of our work is to find contextually consistent information units, which we call root contexts. So what is a root context? A root context commonly represents an individual law on a specific topic, and it is used where a codified corpus's hierarchical structure does not designate a single level for individual laws. At the bottom, we can see the graph of a hierarchical structure of a corpus, where on the top level, we have the title level. Right below, we have a chapter level, then subchapter, and then the section level. What the edges in this graph mean, I will explain in later detail. But for now, it's important to notice that there are 3 stars. And in our case, these stars represent root contexts that our method has identified. And it is important to note here that root contexts can occur on different levels. In order to arrive at the graph that we saw previously, we developed a 3-step approach where we start by building the hierarchy reference graph. We then find root context indicators and finally traverse the hierarchy reference graph to find root contexts. What these 3 steps mean, I will explain now in more detail. The first step of our method is to build the hierarchy reference graph. And for this, we start by finding all the nodes in the graph, which we call hierarchy branches. For example, this node would be described as Title 1, Chapter 1. This node would be described as Title 1, Chapter 2, Subchapter 3. And it is basically the path you have to travel along this tree to get to the node under consideration. In the next step, we try to find the hierarchy references using regexes in the section texts. So for example, if we are in section 30 and section 30 talks about this subchapter, we build an edge between section 30 and subchapter 3. The weights of the edges symbolize how many times a certain section has referenced the particular part. So for example, if section 30 to 35 has 8 references to subchapter 3, we have a weight of 8 here. Since we start at the section level, which is the only level that contains text, we then start aggregating for each hierarchy level, moving upwards. So once we counted all the references here from the sections, we move on to the subchapter. We aggregate all counts from there. Then we move on to the chapter level. We aggregate all counts until we reach the title level, where we also aggregate counts and are done. The second step of our approach is finding root context indicators. What this means is that references in certain sections that contain definitions or purposes carry more weight than regular sections. And we define a set of regular expressions, which you can see in the table, that extract the hierarchy references in these sections. And if one of these regular expressions matches the text within a section, the hierarchy branch of the extracted reference is considered a root context. So for example, if we are in a section titled Definitions, and we find the text, this chapter describes something, we know that the chapter will be considered a root context. In the final step, we traverse the hierarchy reference graph until we identify our root contexts. The way we do this is as follows. For every node in the graph, starting at the section level, we perform multiple hops, following always the outgoing edge with the highest weight. If a node points to itself, we consider it a root context. If a node has no outgoing edges, we move to the node's parent and continue the procedure. So in our example, we start at section 1, we move immediately to chapter 1. Since chapter 1 points to itself, we call it a root context. Similarly, if we start at section 40, we move to subchapter 4, which again points to itself. Therefore, we also call it a root context. In order to validate our method, we perform experiments, and our experimental setup looks as follows. We have 5 different corpora, which are United States Code, California law, Texas statutes, Illinois compiled statutes, and consolidated laws of New York. You can see the statistics of our dataset in the table on the right, where the left column has the dataset name. The second column has the total numbers of nodes in the graph. So these are chapters, subchapters, title, sections, and so on. Third column has the number of root contexts that are identified within each corpus, and which is a subset of all of the nodes in the corpus. And the very right column shows the percentage of root contexts out of all the nodes in the corpus. In order to find a root context, we make use of an expert which annotates each node as whether it is a root context or not. The metrics we use is F1 score, precision, recall of the class under consideration, and classification accuracy. Our experimental results look as follows. On the right, you can see a table which shows again our datasets and the performance of our method on each of the datasets. We find that our method generally achieves high precision, larger than 95. The recall is also high for our state corpora, but less high for our federal corpus, which is USC. And accuracy is close to 1 for all of our corpora. Concluding, I'd like to say that we introduced the problem of finding contextually consistent information units, and we developed methodologies to find these units automatically. In our evaluation, we find that our method achieves high precision and F1 score on multiple datasets. Since our method is unsupervised, it does not require any manual work, and therefore it can be applied broadly to any such application problems. This work further aids Regology's machine learning framework on 3 fronts. We successfully built a keyword extraction algorithm. It increases the performance of existing information retrieval components, and our method was used to extract topics. With this, I will thank you all for your attention. If you'd like to find out more about my research, please visit me at dominicseyler.com.